Hello, welcome to Technoveda Solutions.
In this video, we will discuss about operator overloading. In the previous session, we discussed about function overloading. Now we will see how the operators can be overloaded to function a different operation. We'll see now. As we know, it also comes under a polymorphism. So in the previous session, we completed the function overloading under compile time polymorphism, and second type is operator overloading, which we are going to discuss now. Okay, fine. So what is an operator overloading? An operator overloading is an idea of assigning different meaning to operators without changing its original properties. That means if we have some operator, we want that operator to operate in a different form, but at the same time we are not changing its original property. That means, for example, if you take a plus symbol, it is meant for adding two things, whether it is an integer, whether it is a float, it will be done by that plus symbol. That is the original idea of having that symbol. Now that original idea we don't want to change, or we cannot change. Rather, we use that operator to perform the same operation on the different data types or the objects. Now I want to add two objects. For that, I can overload that. To add two matrices, I can overload that. To add two complex numbers, I can overload that. So using the same symbol, we are trying to implement some other operations which are not part of the basic definition of that particular operator. That is operator overloading. Similarly, we can overload most of the operators. Remember, I said most, not all. There are some operators which we cannot overload, that also we will see. Most of the operators can be overloaded like this to form a different functions. But we should always remember these basic property or original properties should not be altered. Plus means it is adding two things. So minus means it is going to find the difference between the two things. Multiplication means it's going to find the product of two things. Division means it is going to divide between the two things. Like that, that basic properties or a basic idea is not going to change. Now, so here is a syntax. How do we overload the operator? It is exactly similar to how we do any function definition. We have a return data type, then we have a operator is a keyword, then we have a operator symbol we have to give here, whatever the symbol we want to overload. For example, if we want to overload plus, then I have to give a plus symbol here. Then we pass the arguments which will be used for the operations in the function. So it will return the statement, it will take the arguments. All that will be similar to that of any function definition. Only thing is, instead of name of the function, we are writing an operator in place of that with keyword operator. Okay, we can interchange the location of operator and symbol also in some cases. That's also not an issue. So it's all, but it is always better that we mention operator first and then the symbol of the operator, so that it will improve the readability and it will give a proper meaning for the definition of that function. This is how we do the operator overloading. So following operators cannot be overloaded. As I already told you that all operators cannot be overloaded. There are some operators which are excluded from that. Those operators are size of, we cannot overload, type ID, scope resolution, class member access operator like dot operator or a asterisk operator. Asterisk operator is used when we want to access a member of a class using a pointer. When we discuss about the pointer, then we will again explain the how do we access that members using a asterisk and arrow symbol, why asterisk is used, all that operator we will see then. Till now we have only operated on the dot operator. However, this dot operator and asterisk both cannot be overloaded, and one more operator, that is ternary or conditional operator. this also cannot be overloaded. So these operators cannot be overloaded. Other than this, remaining operators can be overloaded to operate in a different form. So size of, as we know, this is the operator which returns a size of an object or a data type which is given to that as an argument. It will find the size of that and it will return the integer value. Size of always returns an integer as a return data type. Then we have something called as type ID. So this we haven't used yet. We will see that in the coming session. This provides ability to recover actually derived type of object referred to by a pointer or a reference. As it's a pointer and a reference is involved, I will explain this when we discuss pointer, and then later session we'll discuss about type ID again. Scope resolution already we have discussed. When we want to define any function outside the class, we use this scope resolution. Basically, the scope resolution is used to identify the context in which the identifier is defined. That is scope resolution operator. Then I said we have two more operators, that is dot operator and asterisk operator. These are used to access the member of the class. A normal object can access the member using dot operator. Pointers will be defined with the asterisk and they will access the member using arrow operator that we will discuss. Then we have one more operator, that is ternary or a conditional operator. This is basically a shorthand representation or implementation of if else condition. So here you can see how it is written. That's an example. First we give a condition. It will check the condition. If the returns of this condition is true, if this condition returns true, then the first expression is executed. If this returns false, then the second expression is executed. It is something like if true, execute this, else execute this. So all the things can be written in a single line. That is conditional expression 1, expression 2. However, remember ternary operations can be nested also. We can have a nested ternary operations. We can define one ternary operator inside the another ternary operator. That is allowed. Then there are certain conditions to be followed for the operator overloading. What are the conditions? At least one operand must be user defined class object. When we want to work on the operator overloading, the operands what we give to that operator, one should be class object. Compiler automatically creates an assignment operator with every class. Okay, we don't have to overload. Automatically it creates an assignment operator overloaded with every class. That's how we, whenever we create an object and we pass a variable, automatically those variables will be assigned to the member variables. That means automatically it can create an assignment operator by itself for the class objects. There's one more called a conversion operator, also can be defined to convert from one data type to another data type. If we want a particular data type which is defined in the float, if we want to convert that to integer, or if it is defined in the integer and we want to convert it into a float, like that we can have that conversion using a conversion operator also. We'll see the examples for that also. Okay, in the we'll see all these things, how to overload all those things with actual code. Now coming to the code. So in the VS Code, we define the C++ code. So this is a header file. Then we use a namespace standard where the memory is defined for our program. Then we define a class with the name OPR. So just to indicate that it's an operator overloading program, I've given a class name. You can give any class name. Then two variables are defined here, data members, that is of the float data type, real and imaginary. Remember again, I have not declared any specifier here. So by default, that will be under private. So I cannot access these two members outside the class. I can access only them within the class. Only the functions which are defined inside the class, they can access these members. We cannot access these members from the main function. Then coming to functions that is defined under public. So we'll be able to call these functions from the main function because these functions are defined under public specifier. Now The first function is get input. As usual, we get the input for these two variables, cout and cin. Already we know how it works, the cout and cin objects. Then we have operator function. So here exactly you can see that OPR is a return data type, that is the object type of this class. That data type only is given because class itself, class name itself becomes similar to an data type. So we are giving a OPR. That means I am returning a object as a data type. Then operator is a keyword, plus is a symbol which we want to overload. This plus symbol is overloaded. Then we are passing an object to the function for the overloading. Now here we are using the ampersand to give the reference of the object, and it will just send the address of that object will be stored in this variable. So that's why we are call this as a pass by reference. Okay. Then we declare one variable here, that is of the object. Again, this is basically an object of the type OPR. Then that is to store the answer. Then we add the two real numbers. This is basically a complex addition. Complex number addition is a program. So in the operator overloading, we are trying to add two complex numbers. So real value is added to the real value, imaginary value is added to the imaginary value. Now if you see, there is only one object being passed, and that object is used here and with a dot operator with the variable or the member. Whereas this variable or a member is directly used without any object name. That means this variable, which is not defined with a dot operator and object name, belongs to the object which is calling this function. There is one object which is calling this function. These member belong to that object, whereas these variable belong to the object which is passed to the function. Okay, so these two objects belong to the object which is calling the function, and these two member belong to the object which is passed as a reference. So here we need to have a dot operator to access these members, whereas here we can access them directly. How it identifies that, and even if we have some conflict, how it will resolve the conflict, that I will explain when we discuss about the pointers again. Now then it will return a object. After adding, it will return the entire this object is returned. Then we have a print statement. So it will print real and imaginary. So now if we are calling this function with the respective object which is returned here, so we are calling that object we are using to call this function, means the result will be displayed here. Now this print statement can be called by any object, whichever object we call, that object real and imaginary value will be displayed. Okay. Then here you can see one peculiar function wherein we are just saying operator. We are not giving any operator symbol here, and we are giving another data type as a int. Okay, remember we have defined both the members as a float, real and imaginary, both we have defined as a float data type. Now using this overloading or the operator, I am converting those float members into an integer members and finding the division between those two members. So this is operator conversion or a conversion operator, where we are converting the members from one data type to another data type. Okay. Then coming to a main function, we just created two objects, object 1 and object 2. So we take the input for both the object 1 and object 2. Then we define another object with a complex sum. So that should be equal to object 1 plus object 2. Now this object 1 is a calling object, object 2 is a passed object. Object 1 is the function which will call the which will be passed by as a called. That is the what we saw here, right? These real and imaginary belongs to object 1, these two will belong to object 2. So that complex number we are trying to add, so these two object members will be given to this function or passed to this function. These two members of object 1 passed by default, these two are passed by reference. Now addition of these two will be stored in the complex sum. Now this complex sum will have the return data type. So we are returning a answer, that is a object type data type we are returning. We are collecting that in the object type data type. So we are passing we are calling it by object, we are passing an object, we are returning an object. Okay, that was one of the condition, right? When we did the operator overloading, we need to have at least one object as an operand. So we are using the objects here to illustrate that. Then we are just calling the print function for the using the complex sum. So this print function will print the result or the addition of these two imaginary numbers with a real and imaginary value of that answer what we get. Then after that we have integer val is equal to object 1. Now this means the object 1 what we have, I want to convert the member of this object 1 into an integer. So that will convert that in integer and it will return an integer. Just by using object 1 like this, it will automatically call this operator. Because there is no name to call this operator, directly I am saying object 1 int val equal to object 1. That means the compiler will check if there is any conversion operator available in the class or defined in the class. Then it will go to that conversion operator, it will convert this real and imaginary of this object and perform the operation and return the integer value back. I can if integer is defined, we can define this as a float. Like that we can have a conversion. Then I am printing the integer value here. Okay, now let's execute the code. So it's compiling, so we don't we should not get any compilation error as such. So okay, so there's no error. So now first is we are called object 1 get input. So we have to enter two numbers. So I will enter both the float numbers 2.4 and 3.6. Then for the object 2 I will say 5.2 and 8.9. Now if you see, I am getting the result. The real part is added as a real number, imaginary part is added as a imaginary number. It is indicated with the I, imaginary part, the sum of the two number. Now object 1, okay, this is the result of that. Then another result what we see is this operator conversion. Here we have 2.4 and 3.6. So that becomes integer conversion, means the fractional part will be truncated. It will be 2 by 3 which returns 0. Okay, so what I do is I will just compile it again and I will change the values. So I will say 5.2 and 2.2. Here I will say 5.6 and 4.8, anything I can give. So this already we have seen, so that we will not get into now. Already we have discussed about this output. Now see, this output we got 2 now. Why? Because 5 by 2 we did, which is a 2 is a quotient. Because it is not giving any fractional value, so that will be ignored. 2 we get as a result of that. That is stored in the val variable. So this is how we overload the operator to perform the operation different than what it is basically or primitively meant for by overloading that. But at the same time we are not changing the basic property of that. It is addition, means we are performing the addition operation only. Okay, if it is the whatever the operator's basic property is there, that we are retaining, that we are not changing. Okay, so this is how we do operator overloading and also the operator conversion or conversion operator. So that's it in this video. Thank you for watching. Hope you understood how the operator overloading works. So subscribe the channel, like the video, and share with your friends. Thank you. Have a good day.